This video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. All I had was 78 grams of the calcium carbonate, so that kind of made my numbers go according to that. Here's my molar masses. Since I had 78 grams, that's 78% of 100. So I took 0.78 times everything. Here I took it times there, which gave me 78 grams. Here we know that there's concentrated hydrochloric acid. There's approximately, a little bit more, but approximately 1 mole per 100 milliliters. I need 2 moles, so I times that by 2. I got 200 milliliters. Times it by my 0.78, I got 156 milliliters, and that's what I used. So what am I going to make? I'm going to make 111 grams of calcium chloride. Alright, now it comes as a hydrate, which is 6 dec. Well, if it's a hex, then it's 6. 6 times 18, which is the molar mass of water. There's 6 of them. That'd be 108 grams. So that's 219 grams total. 111 for the calcium chloride and 108 for the hydrate, the water hydrate. So I'd make 219 grams times my 0.78. I should make 170.8 grams of calcium chloride decahydrate. There is no impurities. The CO2 is no big deal. H2O is no big deal. Calcium carbonate is not soluble in water, so it can be filtered out if I didn't put enough in. I put too much in. I prefer to put too much of this in. That way it can be evaporated away and you have 0 impurity. Now, since I bought this at the Lowe's or whatever, and it's not lab grade, there is something in there that's an impurity. I want you to notice that half of the calcium chloride, is water. You know what I mean? Half of it's water and half of it's, almost, not exactly half. But anyways, here's some solubilities of calcium chloride. 59.5 grams of calcium chloride. These are per 100 milliliters of water. Okay, that's at 0 degrees, 20 degrees, 90 degrees, 100 degrees. You can see the difference is about, what, 2/3? Meaning if you recrystallize this from water and you had 159 grams, 59 grams will stay in solution and 100 grams will precip out, which is about 2/3, you know what I mean, about 66%. But like I said, we're going to, after, normal recrystallization, as soon as it starts crystallizing, you take it off the heat. I'm going to keep heating it up and get rid of a lot more water. I just want a little tiny, 10 milliliters of water. I can see. Well, I got 78 grams of calcium carbonate, and I got 156 milliliters of concentrated HCl, and I'm just going to put it in there. You can see it fizzes vigorously, so it's going to take me a while to do this. So I'll get back to you when it's all done. Now I want you to notice 2 things. One is the color. Look, it turned yellow. So there is impurity. 2 is, this is the last little bit of stuff. I'm going to toss it in so you can see that it is still fizzing. Here it goes. You can see it's still vigorously fizzing. So there's definitely not too much of the salt. There's too much HCl, which is good, because we can evaporate that away. So I got it on the heat here. There's water inside here, heating it up. You can see it's yellow. I'm going to try to get this to boil. Basically just trying to evaporate the water away. I got it boiling here and it's starting to recrystallize. You probably won't be able to see it on camera, but there are little crystals coming out now. Normally now, since it's boiling, since you're getting some crystals, you take this off, but there isn't much contamination in there. I'm going to let it boil even more away. I want to leave at least some water in there because it is yellow, but I want to boil it down more than I normally would for recrystallization. The reason you can't really dry this the way you normally would, meaning just boil off all the water, the hydrate, it's because if you do that, it'll start decomposing the calcium chloride. I'm not trying to make anhydrous, I'm just trying to make calcium chloride. So anyways, I'm starting to smell HCl. No matter how much I heat this, it still only gives me the same amount of precip. And I still smell HCl, so I don't know if I'm degrading it. Maybe I should have just... you can see this is nice clean on one side. Watch when I put it on here. Look at that. Turns red. So I don't know. I'm going to take this off. It has started to have some kind of crystals in there. I don't know if you can see them. What I'll do is I'm going to put it in this pan. And I'll let it recrystallize from there. I shouldn't smell HCl still. Yeah, I didn't put that much extra in. What the heck? So I'm just going to let it, like I said, evaporate naturally. Well, instead of doing it slow, I just decided to throw it into let it cool down. Threw it into the freezer. You can see it's like slush now, kind of like snow. I'm going to throw it in here, into this. Alright, so I'm just going to suck the water out with this pump. Alright, got a little bit of ice water here. I'm just going to turn this pump on and spray it down a little bit with water and wash it out. I'm just going to leave that pump on there for about 10 minutes and let it dry up. You can see up on top I got nice white crystals, all the colors taken out. I don't know if you can tell on camera, but there's no color in there at all. It's just white. Down at the bottom you can see it's yellow. All the yellow color, all the contamination got out of there. So I'm just going to take that as a loss. We're going to dry this up more and see what our yield was. And remember, don't heat this because you're going to, you can eat it a little bit, but it's going to decompose if you try to dry it out to make it anhydrous. If this was, if I used hydrochloric acid but it wasn't store-bought at Lowe's, instead I bought it, or made it at a lab, they have no contamination whatsoever. But because of that hydrochloric acid, I have a loss here now. And no matter what I do, it seems to, like the more it dries out, the more it soaks up water from the air. So I put it in the freezer, chilled it down. I'm going to suck it dry with this vacuum pump. And then I'm just going to weigh it, and that's it. I'm not going to dry it. Because I don't need it to be anhydrous. I just want to... Well, it weighs 95 grams, but it's wet as heck. So my thoughts and suggestions. My first thought is this is terrible. I did a terrible job. It seems like if you heat it up in the oven to evaporate it, you know, to get it nice and dry, you're just decomposing it. It just seems like it just decomposes it, and it gets less and less. And if you just let it do naturally, let it sit out to dry, the crystals, seems like that the more they dry, the more they suck up air, moisture out of the air and end up just being watery. They never kind of, it doesn't seem like you can dry them out. They do have a thing called a desiccator, or I'm guessing that's what it's called. That's what I call it. It basically looks like this pot, this glass pot, only it has a gasket and then another pot that goes on top, so that you have an enclosure, right? And then it would have a little tube coming out so you can put a vacuum on it. And then you would put the calcium chloride in here, right? And you put something else in here that sucks up water, you know what I mean? And try to put the vacuum on it to suck the air out, right? I mean, to suck the water off. And I don't know if that would work. It's just a suggestion, I thought. The only reason I'm making this is because I want to make calcium sulfate, because that's a special reaction on really making anything you want without using acids or any salt, any binary salt. So I'm just going to take it as it is, like I said, but this is just a suggestion. Maybe you know, put it under vacuum for a while. I don't know, that may decompose it too. I really don't know. John Black, Super Chemist. Just wanted to show you some of them crystals. Those is calcium chloride crystals. Isn't that wild? Let's see if I can get some close-ups. I don't know, I just thought those were wild. Looks like a tree almost. Put it down. It looks like a tree. Oh, well, that's calcium chloride right there. Tetrahydrate. Anyways, you all have a great day, and always remember, science is great.